All right, hello, hello, hello. How's everybody doing today? It's my face. Okay. How's everybody doing today? I hope everybody is doing just absolutely wonderful today. We are on track to do good things once again. All right. Eight minutes till hard maths. Ah, man. Hey, math is pretty fun. Let's not kid ourselves here. Math isn't too bad. Good morning, Megan. How are you? Good morning. Good morning to you. I hope things are well with you. How we doing this morning? Good. How about you? I'm doing very good. I'm doing very, very good. It's been a very nice, relaxing day already. So, been watching a new anime last night. What anime are you watching there, Megan? I'm kind of curious now. What anime have we been watching? I can't remember. Okay, that's fine. There we go. Woo, look at this. We got some people trickling in. That's okay. Ready for another rip-roaring day of mathematics. This is going to be fun once again. I just know it. Buenos dias, Athena. How are you? I hope you are doing well, Athena. Buenos dias to you as well. We're here on a wonderful, wonderful morning, so, or afternoon for some others. Good. I'm happy to hear that. All right. know that today's weather is actually rather good, considering it's actually above freezing. Oh my gosh. Yeah, finally some more weather. We'll take anything above freezing at this point. Aiken, you gotta like transfer those files to like your computer so you can clear out all that stuff. A lot of Anna, good morning. Hello, hello. Cheska, good morning to you. Hello, hello. I hope you're both doing wonderful this morning here. We're here back again for another rip-roaring morning here for some statistics. I know that's not the most exciting thing that you may have heard in a long time, but still, hopefully you're having a wonderful day here on Twitch. All right, so enjoying a nice time with myself and the others. So stat speed string at least. That's fair. Stats can be pretty fun. Cool Dad, good morning to you. Good morning to you. How are you doing today, Cool Dad? I hope you're doing very well, my friend. Oh my goodness, it's James Hodges. Oh my goodness, James Hodges. Woo-hoo-hoo. There you go, my friend. James Hodges is in the chat. How are you, my dude? I know this is your last day of... What's good? What's good is some statistics, my friend. We'll be starting in 3 minutes, my dude. I know that today's your last day. There we go. Sorry, muted myself. Nope, muted myself. No, I was gonna say, sorry, James, before I accidentally muted myself. Yeah, I had a wonderful time playing Valheim with you. It's really super fun. You are super fun. Jade and Milky, they're super fun. Pretend to Sar, Ninja, all you guys, really, really great to play with. You know, I haven't played on a friend server in a long time, so it's first Valheim worth getting. Yeah, it's super addictive, Aiken. I ain't gonna lie, very super addictive. I think James spent at least a good 2 weeks on and off stream just playing the game. Like once James got into it, it's just like you didn't hear from James for a while. 100 hours, yeah. Jeez, 100 hours. Oh, Megan. I just read that. Let's see. I log into HBO ReZero starting in another life. Oh, that's a good series. They have 2 seasons of that. ReZero starting in another life, very good series. Very, very good series. It's tragic, but it's very, very good. That is an excellent series. Like at first it'll be very confusing, but yeah, at first it'll be very confusing in terms of the plot, but then once you get closer to the end of season 1, then you'll understand exactly how all the pieces are kind of put together. So at times season 1 can be pretty frustrating, but once the pieces are put into place, you're like, "Oh, I finally get it." So, yeah. Good times, good times. Woo. Wow, it's a lot. All right. Okay. Well, we got to get started here. It's 11 o'clock already. Woo. Well, that didn't take very long. All right. Cheese and crackers. Wow. All right. Well, in any case, let's go ahead and get started here. Let's see what we can do with things. All right. Alrighty, let's get started. Let's do the intro. Let's do it. Okay, let's get started today. Welcome back to Wednesday, end of the week time today. So today we're going to continue where we left off last time. Last time we finished off section 5.3. We did some work together here, and again, hopefully a lot of the stuff that we talked about in section 5.3, which was talking about ands and ors, and talked about that the past couple sections here. But now we did the mutually exclusive kind of disjoint independent events. Okay, we talked about how to kind of handle those two guys. Um, so we know how to deal with probabilities on those ends. Today we're going to deal with another type of probability here in section 5.4. Okay, so section 5.4 here is where we're going to be dealing with another type of probability here. So let's take a good look here at the big board and let's see exactly what we're working with. All right. So here we're on the second half of the handout from last time here. We finished off the first two questions here talking about independent events. Like I said, I hope those examples there that we did last time hopefully cleared up a lot of the issues that we had from before. Actually, before we get started here with section 5.4 here up on the screen, does anybody have any questions from last time? Any questions from last time? Any questions at all? Nope. All right. Nope. All right. Ah. Nope. Okay. So you guys are pretty cool about just all the examples there. You know, hopefully that cleared a lot of stuff up. Is that right? Hopefully. So question mark, question mark, question mark. So if you're having a little difficulty with the examples there, again, you could go back through the replay. You could watch it again, and then you can see exactly kind of what we did there. So hopefully, though, through the discussions there, we had hopefully that made it a bit easier. Let me ask you a poll question here, really quick. One of the things I'm not super, not on the fence about it, but I'm just going to put a short poll here, be a short 2-minute poll here about. Okay, you changed it from BMZ. All right, that's cool, Ziggy. Right on. I'm gonna put a little poll here. Just if you like the Discord portion there. Again, I just want to, hearing your voices is very important. And again, you can immediately ask questions if you have. So if you liked it, you could put yay, and if you like said it smells, then you could put nay. You know, well, hey, Samantha, how are you? I hope you're doing well. Samantha, great to see you. How's your semester so far, Samantha? You guys can vote there, either yay or nay for Discord there. I know some people don't like the Discord, but I understand that. But I try and get people involved as much as possible. It's meh. Why is it meh, Samantha? Like I said, some people I like the Discord because then I can talk to you directly, and then you can answer that there. Neurotic, good to see you, my friend. Good to see you. Not understanding your classes? Oh no. Well, you can come to me if you have some help. If you need some help for math, there, Samantha. Okay? All right, just a little bit more time here. Okay. You like talking to me, but I can hear you, cool dad. It's fine. Okay, so a lot of you like the Discord portion here, so we'll be doing more So majority of you like the Discord portion. We'll be doing some more here with Discord. I appreciate the feedback there. Just to say, hey, this is working for me. I said, okay, that's fine. It's fine if you break up a little bit, Cool Dad. It's not a problem as long as I can effectively communicate things to you. It'll be, and you understand what I'm trying to say. Cool, I'm down with this. Everybody's just fine. Okay. In any case, thanks for the feedback. Appreciate you. All right. Now, let's go over the objectives here for section 5.4 here today. All right. So today, in section 5.4, we're going to be computing conditional probabilities. All right. So let's talk about conditional probabilities. That's the next one here on the docket. All right. So we're going to do two things here. We're going to compute conditional probabilities here, and we'll compute probabilities using what we are going to call the general multiplication rule. Okay, so let's take a look at number 3. What is a conditional probability and what is its notation here? Now we are going to be using particular notation here for given probabilities, so this is certainly something to write down. So first of all, the definition of a conditional probability. A conditional probability is the probability of one event B given that an event A has occurred. Okay, so conditional probability, the probability of one event B given that an event A has occurred. So we're given a condition that, hey, some other event has happened. Now what's the probability that another event has happened given the first part has already happened? So we say the notation here, let's take a look at the notation here. Notation here is the probability of B and then this kind of straight line here and an A here. Now we do read this in order here, so be very careful regarding this. We do read this in order. This is the way we read this is we say this is the probability of B, and then this line here means the word given. So the probability of B given, and then next to that line there is the condition here, which is event A. Okay, so the probability of B given A. Okay, so again, I will be saying this over and over and over again. So again, at least you know that our given condition is always the second letter. Our actual probability that we're trying to find is going to be this first letter here. Okay. Now, let's take a good look here at how we can compute conditional probability. Now, computing conditional probability as yes, Jade, that's right. um, So computing conditional probability says the probability of B given A is the probability of A and B over the probability of A, or the number of A and B divided by the number of A. So I just kind of, again, as one of the things I talked about earlier is I'll write it in letters and I'll write it in words. So that's what both of these represent here. This is in letters here up top, and this is in words on the bottom. As I kind of pointed out here, sometimes for some people it's a lot easier if you just write out in words. So there it is. Okay. Now, one thing to understand regarding conditional probabilities is I put this note here because oftentimes people assume that something is true, but it really is not. And that is talking about this part here is that the probability of B given A is not the same probability as the probability of A given B. So if you flip the letters around, okay, they are not going to be the same probability. So in this case here, let's go ahead and put a second note here. I think it's worthy here. Note number 2, order matters. All right, order matters quite a bit when it comes to conditional probability. Oh my God, it's Connor. Yeah, order matters quite a bit. The probability of B given A is not the same as the probability of A given B. They are two different circumstances because of the condition that's actually given. All right, so you have to be a little bit careful about that in this case here. Order matters 9 times out of 10. I disagree with that. Circumstances show that sometimes it does and sometimes it does not. Like, for example, Connor, we'll look later in this chapter, we look at the lotto. If you look at the lottery, order doesn't matter in the lottery. Okay, and you actually have to adjust for that fact because order doesn't matter in the lottery. If it's a race, order matters, but if it's the lotto, order doesn't matter. So yeah, it does vary circumstance to circumstance. So you'd be surprised. In probability, that's actually the case. Okay, now having said that, of course, we need to talk about how we can go ahead and solve for this particular these particular rules here. So let's go ahead and do that right now. All right. So let's see here in book here. There we are. Okay. Now to kind of showcase this off here, what we're going to do is we're going to do one example here together. And this will hopefully make things a bit easier about how to approach certain probabilities. So let's take a look on how we can go ahead and do that. Fair enough. All right. I'll bring out the paint tool here for this one. There we go. There's the paint tool. There. All right. Okay, so I'm going to look at this table here. All right. So let's take a look at this table, number 17. All right, so let's look at number 17. Okay, so number 17 says made in America. So it says in a recent Harris poll, a random sample of adult Americans 18 or older was asked, when you see an ad emphasizing a product that's made in America, are you more likely to buy it, less likely, or neither more nor less likely to buy it? And so here we're given a table here. Now this table here is something we'll actually explore more in chapter 4 when we get to the end of the book. But this is what we call a contingency table. Again, we have some categories here. We got, again, categories on the side, categories up top. All right. Now, based on this contingency table here, we can actually figure out conditional probabilities. Okay, so we're going to answer several questions here using this table here. And again, we want to just at least you have the numbers in front of you here on the screen, so that way you can see exactly how to approach some of these problems. Okay, so let's look at letter A here. I'm going to kind of read it off. It's on the next page. It says, what is the probability that a randomly selected individual is 35 to 44, given the individual is more likely to buy? Okay, so we're going to try and find the probability of 35 to 44, and then we'll write given more likely to buy. Okay, so let's go ahead and figure this out here. So I'm gonna guide you through how this is going to work. Now, the first thing that we're going to clue in on, is we're going to clue in on more likely. Okay, this is the given condition that we're given here in this problem. So this is our given condition. This is the condition here. So if you need to say it out loud if you need to. Okay. Again, you read it from left to right. The probability of 35 to 44, given that we're more likely. Okay. So here's how it works. If we're given the condition here of more likely, we're first going to look here in the table and say, well, how many people are more likely? According to our table here, the number of people that are more likely is going to be 1,329. Okay, because it's, again, I'm looking within just this narrow point of view. Just this narrow point of view of more likely according to our table. Okay, so 1,329 is what I get down here. This is the number of people in the more likely category. So then the question becomes is, what's the probability that I get 35 to 44? Well, how many of those 1,329 people are between the ages of 35 and 44? Well, if I take a look at the table here, in that category specifically, the number of people that are 35 to 44 in the more likely category here is 329. Okay, so that would be this one here. So then I'm going to have 329 over 1329. And now I can go ahead and use the calculator here, and I can figure out what this is as a decimal. So if I do this out here, I get 0.2476. Okay. All right. So Cool Dad tells me to wait. That's fine. Is it this? Okay. So understand, Cool Dad, that not quite, unfortunately. Okay. So I want you to understand where we're getting some of these values from, Cool Dad. All right. So slow down here for just a moment. Okay. Go back to the very beginning of this problem here. The first thing that we need to do in these problems here, Cool Dad, is we need to go ahead and you need to read it from left to right. All right, so let's put that as one of the keys here, because if that happens to be an issue, I'd rather clear that up now than later. Okay, so one of the keys is that key is read from left to right. All right. I don't want you to take it as two separate probabilities here, Cool Dad. I want you to read it from left to right. So it's the probability of 35 to 44. And then again, with this line here being the word given that you're given that it's more likely you're going to buy something that said made in America. So the probability of 35 to 44 given more likely. So I'm combining two things here. First of all, I'm looking at the condition that I'm given here. That's this right-hand side you see here, the more likely side. How many people were more likely? According to our table here in number 17, it was 1,329. Well, how many of them are 35 to 44? Because that's the condition we want to look in inside the more likely category. That was 329. If we go back to our notes here for just a moment, you can see I effectively have done the same thing. Notice that I've taken the number of A and B, the number of 35 to 44 and more likely, divided by the number of more likely. All right, I've essentially went ahead and did that here in this particular circumstance as well. Okay. I hope that clears that up there. Before I move on here, are there any other questions? So before I move on here, are there any questions? Boehner, all right. Today I have Dr. Pepper from my friend bought me like a 1 liter of Dr. Pepper from yesterday. But if you guys think that this drink is too boring because you've seen Dr. Pepper like 10,000 times, okay, then I can go get another drink that I bought from Mitsuwa yesterday. So I did buy a bunch of drinks from Mitsuwa. So no. Do you guys want me to get another drink other than Dr. Pepper? Or do you guys want or is Dr. Pepper okay? If I can go get another drink, that's fine. Dr. Pepper's decent. Okay. Dr. P is pretty decent, yes. Another drink would be cool? Okay. What are the odds of drinking Dr. P right now? What? True. All right, let me go get another drink since it was asked. Let me go and swap out my drinks. Hang on. I went and got a lot of And got a lot of different drinks for upcoming streams. I know you guys like the variety I bring. So today's drink here is going to be Asahi's Gun Gun Gurt drink. It is a yogurt drink, a sweet-ish type of yogurt drink. Okay, that's what I got here today, and I bought yesterday from Mitsuya. Okay, so got me my Asahi Gun Gun drink here, my yogurt drink. So let's see how this drink goes. A dirt drink. um, no, it's called Gun Gun Gurt. Megan. It's called Gun Gun Gurt. So Gun Gun's like energy, kind of an energy kind of a saying. So Gun Gun Gurt. It's got a very smooth, nice aftertaste to it. I like it. I like it. I was kind of on the fence about this one, but yeah, this one's actually pretty decent. Pretty decent. This one's actually pretty decent. I like this one. Yeah. Yeah, that one's it is yogurt flavor, yogurt flavor. Yes. we got yogurt type of flavor here. Yes. So it's just pure plain yogurt type of flavor with a little bit. Yeah, it's plain yogurt here, but it's got like the hint of sugar there that gives it that extra taste. This was made by okay, so it's made by Asahi but distributed by Calpis. Okay. Got it. It's good. It's pretty good. So again, everybody's got a different flavor profile. Um, all right, so that's our drink right there. There you go. All right. Asahi makes a lot of different drinks, Ziggy. So although a lot of people know Asahi for its super dry beer or things like that, Asahi makes a lot of different types of drinks. So for example, it's like Coca-Cola. Okay, everybody knows Coke for making pop. Okay, but Coke makes a lot of different drinks outside of just pop. So in Japan, you can actually find this in Mitsuya as well, but they make a energy drink as well. So this is like I'll put this up on screen here. So this is Aquarius. Aquarius is like a energy drink in Japan, and that's made by Coke. So a lot of different types of drinks made by different companies. So although we only get a small amount here of what they actually make, go to other countries and you'll certainly see a lot more variety. All right, so let's go ahead and take a look here at the next one here. So the next one I want to talk about here is what is the probability that a randomly selected individual is more likely to buy a product given the individual's 35 to 44. So let's reverse things around, okay? So let's flip it around. So let's say the probability of being more likely given 35 to 44. Okay. So let's go back to our table here because we're going to need it. All right, so the probability of more likely given were 35 to 44. Let's answer this in two parts here, okay? Let's answer this in two parts. Let's take a look at our given probability here first. We're given 35 to 44. How many people are in the 35 to 44 category according to our table? Made you mad. Subs with the prime, man. Geez, 6 months. 6 months. It was 6 months. You're out of your mind. 6 months, holy crap. I don't believe it. I don't even know why you want to sub the channel for 6 months. Unbelievable. That's close, Fader. So 35 to 44 category. What's the total in that category there? Yeah, total here, yeah, exactly. 536. Right. So then the next part here is that say, all right, I find the thank you so much, Made You Mad. You're legendary. The next part here says 35 to 44 here. That's how many people we have overall that we're going to check within. So then how many people in that 35 to 44 category are more likely according to our table here? So we're just looking within this narrow window. How many people are more likely according to the table? That's right, 329. That's right. So our probability here is 329 over 536. Okay. Now, that's big brain. There you go. 329. Perfect, Ziggy. All right. Now, thing is, I want to actually state this here. Everybody's got big 400 IQ in this channel. All right. Unfortunately, I'm kind of lagging behind you guys, so apologies about that. All right. Now, I do want to state why I did it in this way. Okay. I did do it here this way on purpose. Okay. One of the most common mistakes I see about conditional probability is people getting probabilities above 1. All right, is they put the numbers in the wrong places and then you get a probability of above 1, and then what you're basically telling everybody is that there's over 100% chance that something is going to happen. And that just can't happen because only probabilities exist between 0 and 1, or 0 to 100%. So I always start with the bottom number here first as well, what window are we looking in? Exactly how many people are between 35 and 44, since that's our conditional probability, since that's our condition here? Well, we have 536 people that are between 35 and 44 according to our table. Well, how many of them are more likely? That's what I'm going to put up top. Well, that's 329. Okay, put 2 and 2 together there. There you go. I will definitely get something that is between 0 and 1 at the end of the day. So one of those common mistakes I see quite often with these type of problems here, want to be sure that you're aware about that as well. Let's take a look at another example here. Let's now this time here, I'm going to give you guys the opportunity. I've guided you these last two problems here. Let's have you guys try one for yourselves. Let's do letter C here. Let's do the probability, and I'm just going to make this up here. Probability of neither given 55 plus. All right. So what's the probability of neither given 55 plus? So probability of neither given 55 plus. Could you guys tell me what you get as a fraction? Okay. So Aaron, I know that's not true. That's the So the issue with your answer there, Aaron, is that you'll get something above 1. So then you'll fall into that trap that I talked about before. So watch where your numbers need to go. Start with the bottom number, then go with the top number. What time is next class? Next class is at 12:30, as always. So I see several answers here. So Aaron, what do you get if you change those around? Yeah. 118 over 765. Okay. That's okay, Athena. You could always come back for that one. Not a problem. Okay. Cool, cool. All right. We'll see a lot of good answers here. So Cool Dad says 118 over 765. A lot of people say 118 over 536. Let's take a look at our answer for this one here. First thing we're going to do here is figure out how many people are in the 55 plus category. Remember, that's our given condition. So there are 536 people in this category here. All right. And there'll be 118 people. So in that 536, out of those 536 people, 118 were in the neither category. So indeed, it would be 118 over 536. Sorry, Cool Dad. Apologies, my friend. That's okay, though. That's why we go over this stuff here. And so we get 0.2201. Hey, we're all human. It's all good. We're all human. I have no problems with any of this. All right. So okay. Okay. Let's have you guys see what we get this here. Oh right. Okay. Fine. Okay. Okay, that's fine. All right. Now I might want to do one more here. So yeah. Let me bring that one up here. So I'm going to bring up a problem here. I normally don't do this one, but this one is one of those problems that can occur from time to time. So this is actually on a really old test of mine. Let's see if I can find it here. It's one particular question that uses this pretty nicely. So, oh, thanks. It's a revolving background. I just like space themes, so I just kind of have a revolving space theme background. So I just got like yeah, I got like a bunch of them and just kind of put it together. Where are you? Yeah. You heard about Daft Punk? Rip Daft Punk. You heard about Daft Punk? Yeah, rip Daft Punk yesterday. They broke up. I remember when they were in the Tron movie. Totally rip, man. Totally rip. Where did I put that thing? Okay, that's that one there. Trying to find this thing. Where did I put you? Well, I mean, it could very well be that they are kind of got done with each other. I mean, you never know. Artists have their reasons, I'm sure. Okay, here we go. This is the question I wanted to take a look at. All right. Okay, so I'm going to put this up here. This was actually a test question that I had in my previous classes. So if they were to take a paper-based exam, this would be a very fair question to do given probabilities. This one doesn't have a chart per se, but it does have some values in here. So I want to have you guys give this a try. All right, so let's have you give letter C and letter D here a try. All right, so just parts C and D here. So you don't have to do parts A and B. So do parts C and D. All right. And then I'm going to ask you, I'm going to go ahead and ask you here in maybe a couple minutes here about what you got for parts C and D. So you guys have to try this on your own here, and I will ask in a couple of minutes. Okay, so go ahead and give that a go. Remember to read the problem very carefully, so be sure that you get that down. Let's give it a go. Okay, so you will have here. Okay. All right, so let's look at C. Let's look at C. So go ahead and read this off here. It says, given that the person is a female, so C, it says 25.8 over 50.8. All right, let's see if that's correct. So given that a person is female, what is the probability that she has a management job? So the way I could write this here, go ahead and just kind of shrink it down here for just a second. Get with our paint tool here again. All right, paint buddy. All right, so here we have, given that the person is female, did 25.8 over 64.5. Okay, so there's two possible answers here. Let's see which one is correct. You need to look at both. So the probability that it has a management job, I'll put the management job, given that it's a female. Okay, so we first look at our number of females, right? So again, if we write it out here, the first thing that we have to look at is the number of females. So how many females do we have? According to this, we have 64.5 million females. Okay, we have 64.5 million females. Well, how many of them have a management job? Well, according to this, 25.8 million had a management job. So our answer here for this one here is 25.8 over 64.5. So remember here, go in order. Always go with the condition first. Always go with the condition first, cool dad. So you should always go with the condition first. If the given condition is female, we want to look at the total number of females. Okay, I know this is, look, I understand it's a rough go. That's fine. That's why we're going through this carefully and slowly, okay? So this is not a knock against anyone. This is just about, hey, let's just try and smooth out those wrinkles there. Always look at the condition first, and then go ahead and proceed to find out how many people within that small little bubble follows that particular probability. So in this case here, that's what we want to do. We have a 25.8 divided by 64.5. Okay. And so here we get a straight up 0.4. Okay. All right, so that's part C. How about, did you guys do part D? About part D. About part D. Given that the person has a management job, what is the probability that that person is a female? About part D. 25.8 over 50.8. Okay. All right. Okay. All right, that's fair to say. Okay, well, let's take a look here, and let's see how we can get along. All right, so given this, we have the probability that the person is a female, so we reverse things around, right? Probability that someone's a female, given that they have a management job. So we're going to look at how many management jobs there are first. And in this case here, management jobs here, we have 25.8 million for 25.8 million plus 25, since that's given to us here in the problem. All right, so I agree with everyone. They say 50.8. And of course, how many of them are female? Probability that they're female here. Well, of those, the women comprise of 25.8 million management jobs. So that is correct. 25.8 over 50.8 is correct. Yes. Good. I win. I win. Yes. All right, so we get 0.5079. Okay. You do that here. So you do that here. 0.5079 is correct. I like virtual high fives. This I agree with. Fist bumps. Okay. Well, virtual fist bumps for everyone. All right. All right. Good job. So yes, indeed. This thumbs ups for you, Cool Dad. Good job. And for Megan. And for everyone. All right. Okay. So we went over those two examples there. Are there any questions about that? Any questions at all about that? Yes, Siggy. Everybody gets a thumbs up. That is nothing wrong with that. No questions? All right. Good stuff. Let's take a good look here at the next question in the handout. You have to proceed here. Okay. So let's talk about the last two questions here, okay, that we do have to cover here in this handout. All right, so number 5 here, what is the general multiplication rule? So the general multiplication rule basically is a reiteration of the previous rule here. I'm going to zoom out here for just a moment. So if we look at the previous rule here, it's just basically using a little algebra. So essentially you have the probability of B given A is equal to the probability of A and B divided by the probability of A. If you just multiply by the probability of A on both sides, then this is what you essentially get. You get this right here. The probability of A and B is equal to the probability of A times the probability of B given A. Now, we sometimes will use this here. But in a more practical setting, we can actually just figure it out via brute force. So we will use the general multiplication rule. This part is true. We just will use it probably more in the brute force fashion as opposed to using it maybe as it's stated right here. Just because it's like, okay, you can pretty much kind of put those two together. It really isn't that hard to do. Now, having said that, though, where does this kind of fit in? Where does this general multiplication rule kind of fit in? Well, one of the things that we talk about here in this section is we talk about sampling with replacement and without replacement. And this is where one of those times where we talked about independent events where we said, okay, two independent events means one event doesn't affect the probability of the next one. In this case, it can, okay? But with the condition, of course, that if it comes with replacement or it comes without replacement. Now, with replacement here basically says exactly that. You replace the item back, okay? So you have the same number of items for each pull. So if I'm saying if I have a deck of cards, for example, and I pull a card out of the deck, whatever that card is, I don't really care, but I put the card back in the deck. That's with replacement, okay? I'm going to have 52 cards in the deck. I take one card out, I look at it, like for maybe for a magic trick, I put it back in. If the same 52 cards still exist in the deck, all right? That doesn't matter. The next one here is without replacement. So you don't replace the item back, okay? So you have one less number of the items for each pull. This is especially true in like Texas Hold'em poker. Okay, so if you have a 52 card deck and and you're playing Texas Hold'em, all right, you get two cards, okay, whatever those two cards are, it doesn't matter. But now there's two less cards in the deck, so now for the other cards there, now you have 50 cards of which can be put out as your best chances of making a pair, whatever is the best combination. There are more people at the table, of course, then that means there's even fewer cards in the deck for you to go ahead and choose from out of those first initial 52. Okay, so that's without replacement. Now, as I pointed out here before, and I made this note here once again, we have to be very careful about the keywords there, such as we talked about last time, such as the words at least. You remember we talked about the words at least, and we can talk about the words exactly. Words at least or the word exactly, probabilities must be done differently. Okay, so remember, at least had its own kind of probability because there could be more cases involved. Exactly means that there's going to be just that exact one case. And so that's going to take care of just one particular individual case, as opposed to at least being many multiple cases. Okay, now having said that, of course, we need to look at some examples here. You go ahead and see what happens with or without replacement here, given the circumstance. All right. So let's look at some problems here. Shrink this down here for a second. Go back into the textbook. All right. All right. Alrighty. So let's take a look here at number 27. Number 27. One of my favorite questions here to do. Just because of how it can be realistic here if you have an old CD. If you have an old CD player, yeah, or even a digital player, you're putting on random music. Is it really RNG? I guess that's the real question. Um, All right, so let's look at 27 here. 27, suppose that a digital music player has 13 tracks. After listening to all the songs, you decide that you like 5 of them. With the random feature on your player, each of the 13 songs is played once in random order. Okay, find the probability that among the first 2 songs played, letter A, you like both of them. This would be unusual. You got a record player? Yeah, there you go. Record player. Yeah, man, I remember when my family used to have one of those. Back in the 80s. Old school record player when you had vinyl. That's pretty legit. From the 70s? Yeah, I think was ours from the 70s too? It was an old Sony. It's old Sony vinyl player back in the day. My dad used to get a bunch of electronic stuff, so yeah. I don't know if I don't think we have it anymore, but yeah, I think we had like a Sony like from the 70s because my dad came here in the 70s. So in any case, uh yes, let's right. Let me attempt to do problems. All right. Whoops. Erase all of you. You have a Denon? Wow, that's old. How old is it, Ziggy? Okay. All right. 1977. Respect, my friend. Respect. Respect. I wasn't born yet in 1977, even before my time. And I'm an old man. It's 2 years before I was born. So there you go. All right. So we have a digital music player here. We have 13 tracks. We listen to all the songs. We have 5. Vinyls are very aesthetic. That part is true. Um, so we like 5 of them. So we like 5. Okay. So 5 out of 13 songs on a record or on a CD or on any album. You know, there's a certain amount of songs that you're gonna like. Um, you know, it's gonna be like that here. Um, there's only one CD that I actually legitimately liked most of the songs on. Let's see. Yeah, that was the first NSYNC. The first NSYNC album was actually during that time was actually pretty catchy. So I'm like, during the height of the boy band era. I'm like, yeah, the first one had a lot of good songs on it. It was the only CD that I would think would probably be worth buying. So in terms of material, so I'm just saying. I know you guys are like, that's weird, man. Be like, no, it's not. Okay, it's not. It was good for its time. I won't lie. Um. All right. So here we have like. We have like a 5 here. We have a dislike, okay, or a dislike, or maybe you're kind of meh about. But maybe if I can spell dislike at some point, I'll let you know. At some point, I'm gonna get this right. So dislike here we have 8. All right, so we have 13 total tracks here. We like 5 and we dislike 8 of them. Okay, so let's take a good look here at letter A. Okay, let's go with the first track and the second track here. So first and second. Okay, drink stream. Red, white, and blue Beatles? Connor, if you want me to do a drink stream, just a drink. I don't drink alcohol on stream, but I just drink nice, nice drinks, nice different types of drinks. I'm a lie. All right. So the first one here for the first song. So let's say we listen to the first song here. Okay, so we listen to the first song. What is the probability that we like that first song? What's the probability that we like that first song? Yep. Okay. Good. That is correct. 5 out of 13. That's right. Okay. Now, 5 out of 13 is right. Okay, so I agree with that. Now we're going to multiply that by the second song. Now remember how it's going to work here. Specifically how this is going to work. If this is going to work in an appropriate manner, okay, that means that once we play the first song, it's not going to come back until all the other songs have been played. Okay, so this basically means in this particular instance is that we're going to do this without replacement. All right, so that's going to change things a bit. Okay, that means that next song is the same song can't come up again. All right, and that's not possible. All right, remember each one of the 13 songs has to be played once before it shuffles back. So the second song here, what's the probability that the second song when we listen to is another song that we also like? Very good, Toaster. That is correct. Very nice. So, all right, so here's where we need to be careful here, okay? We have 4 songs left in the pool, right? Because now we've already taken away one song that we like. So now there are 4 songs left in the pool. But since we also took away one other song, then that's 12 songs left. 4 out of 12, right? 4 out of 12. So let's talk about this here carefully. Okay, we went from 13 songs. The first song has been played. So now we have 12 songs left. We have 5 songs. One of the first song we found out we liked. The next song here, that means that there are 4 songs left that we like. Okay, so we have 4 songs left that we like out of 12 songs left in the pool. So we have 4 out of 12 for the second song. That's if we like both of them. Okay. So we like the first one, there's a 5 out of 13 chance. If we like the second one, there's now a 4 out of 12 chance because the pool has shrunk. Does that make sense? Are there any questions about that? Uh, yes, if there was a third song there, Megan, yes, that would be correct. 3 out of 11. If the third song was the next song that we like, then it would be 3 out of 11. That's right. That is correct. Okay, so let's multiply these two things together. So here we're gonna again just multiply these guys together. 5 out of 13 times 4 out of 12. All right, get 0.1282. Okay. Let's try the next one here. You like neither of them. Okay, so let's look at this here together here. You like neither of them. So neither one of them really appeals to you in any shape or form. You're like, eh, that's how you see it. You're like, eh, okay, eh. All right, it ain't that interesting. Eh. All right. So you're kind of meh on it. So again, so let's go with again not like or dislike, and then again let's go with dislike. So let's keep the language the same. Keep the language the same. Need to not like to. The first one is dislike, and the next one is also dislike. Okay. So the first one there, all right, that's correct, Megan. 8 out of 13 here. You dislike that song. So that's your odds of your first song. You say, I don't really like that song. It ain't my cup of tea. Okay, you have 8 out of 13 chance of that song appearing. Okay. How about the second song there? So we're not replacing, going without replacement. What's the probability in that case? 7 out of 12. That is correct. Very good. That is absolutely 100% correct. Very nice. And we'll multiply these together. And I think that's right, Cool Dad. Let's check that. Check that. Yeah, 3590. That's right. Yep. Okay. So far, so bueno. All right. So far, so good. All right. I know. Nice. Yes. I approve. I approve. Okay. Let's take a look here at letter C. Hey, look, that's right. Positive progress. Okay. Positive progress. I like this. Okay. Positive progress. Making very good positive progress. I gotta stop shaking my hands like this. Every time I shake my hands like this, I think alien. Okay. Gotta stop doing that. Anyway, what's the probability that we like exactly one of them? Okay. Probably that we like exactly one of them. So okay. All right. So the probability that we exactly like one of them. Now, this one here is a little tricky. Okay. Admittedly, this is probably the trickiest of the problems here, so we need to be a little bit extra careful. Because in this case here, we're going to have two cases. Okay, now the reason why we specifically have two cases involved here is because we're doing this without replacement. So one of two things can happen. Either the first song is the first song we like out of the two songs, or the second song happens to be the song we like out of the two songs we listen to. Okay? So we're going to have two cases here. So let's write down both of those cases. Okay? So maybe the first one we like, and then we go dislike. Okay? So that's the first possibility. Or, again, the second possibility is that we dislike and then we like. Okay? So we're going to add these two guys together here, and we're going to come up with the probability because they're two separate cases here. They both have a plausibility that would satisfy this particular condition. It says exactly one of them has to be a song we like within the first two songs that we listen to. Okay, so we're taking both of them into account here for this particular example. Now, let's see. Cool Dad, you have said 5 out of 13 times 8 out of 12. Okay, right. So we like 5 songs. As we kind of stated up here, we like 5 of those songs, and there are 13 in the pool. I agree with that. And for dislike here, we still have 8 of them in the pool that we dislike, but now there are 12 that we can select from. Right. So I agree with that first part there. And then you put the second one here, dislike. If we have a dislike here, we have 8 out of 13 here. Actually, let me think about that for a second. Does that matter? Or am I adding both of those together? Check that really quick. Does order matter here in this case? Or do we get the same thing? I have to be sure. Yeah, that's... Okay. Nope, we're fine. We are fine. All right, so, and then what we like here, we have a 5 out of 12. Order does matter here. All right, we're okay. Okay. So that's correct here. Yes, okay, so I agree with both here. And if you go ahead and add these up together here, we are going to get point... The answer here is 0.5128. Yes, cool dad, that's true. You are definitely smarter than a 5th grader, cool dad. Congratulations! Yay! All right. Yeah, that's correct. All right. Great. Nice job. Nice job. So that's without replacement there. You can see how the odds change depending on what happens each time down. If it's with replacement, you would have the same pool of songs. If it was truly random, then that same song can go back in, at any time. So if we were to look at, say, if let's say there was truly RNG, okay, it was truly random, and it had with replacement here. So let's look at that here really quick. So this will be this example here. Let's say we have the let's say this is with replacement. So with replacement here, it's even easier. So the reason why I go without replacement first, because it's the tougher of the two cases. But with replacement, it's super easy. You take the probability, let's say the first two songs, so you like the first two songs. So in this case here, you'd have a like and you'd have a like. So there's a 5 out of 13 chance that you like the first song. But if it's truly RNG, okay, and it's like if it's truly randomly number generated, it's truly, truly random, you put it back into the possible songs that you can select from, you can get that song to show up again. So you could get like 5 out of 13 again, and that would be your second chance. Again, same pool of songs here. Again, you have the same number of choices, which is still 5. All right, you're not reducing that by 1. And then you could go ahead and multiply those together, and then you'd be good to go. So in this case here, we get 0.1479. Okay. So you can see that with replacement here, it's even easier than without replacement because you don't need to worry about that in that case. So I'll be a little bit more specific here, Feiner. What I'm telling you is that within the first two songs, randomly generated first two songs, within the first two songs, you will like exactly one of those two songs. Yes, there's a 50% chance. That is correct. Slightly over a 50% chance you will like one of those two songs. Correct. Within the first two songs. Given those conditions, of course, though. Yeah, within the first two songs, right. So we're given the condition here that within the first two songs will exactly like one of those first two songs. So hence why it's above a 50% chance. So for without replacement, you reduce the probability by 1, and with replacement, the probability stays the same. Yes, so again, that's correct. We reduced the pool of songs. In this case, we reduced the pool by 1, all right? And we looked at, how many possibilities we have in, each category. That's right. And then, for the for with replacement here, yeah, we kept the same amount of 13 songs here. So notice we have 13 and 13. Okay, but in this case here, we went from 13 to 12 without replacement. So that's right. So hopefully that made it a bit easier to do. Why does A and B go up, but the probability of C goes down? Okay. So, why does A and B go up? I'm a little confused what you mean by that. Cool, Dad. What do you mean by A and B go up? Like, because in this case here, we like the first song here, so we have a like here. The first one we like, and the second one we like. So we have 5 out of 13 songs for the first one with replacement. With replacement A and B. A and B are higher with replacement. C is lower with replacement. Yes. Uh, these are all without replacement, by the way. With replacement, it would be very different. So with replacement, it's different. So with A and B here, the reason why with replacement is because you still have the same pool of songs, and nothing changes, right? The 5 songs you like and the 8 songs you dislike, those pools don't change. So you're not limiting your pool of songs, okay? So with replacement here, you have more possibilities. Thus, you can increase your odds again. Without replacement, though, that's again narrowing your focus down. So, you did D. Oh, okay. Oh, yeah. Let me look at D there. You did D there. D. Redo A through C if a song can be replayed for all songs. Okay. Yeah. So if we were to look at if this would be like for letter A again. Let's see. The next one here would be the probability for like neither. So this would be, in this case here, this would be 8 out of 13 divided by 8 out of times 8 out of 13, since you like neither of those songs. So here we got 0.3787. And I think the last one here you would get first two songs here, so we get 8 out of 13 here, and 5 out of 13, plus another 8 out of 13. Actually, well, other way around, really. It doesn't really matter. With replacement here, it doesn't matter, so not too much. 5 out of 13 liking that first. So you get the same numbers here. And all right, so here we get 0.4734. Okay, so to put context here, here we got a slightly lower probability for the last part here. I think that's what you were referring to here, Cool Dad. So yeah, we get a slightly lower probability here, and that's because of the fact that we could end up in one of these two cases here. Again, with the 8 out of 12 here, with the one less replacement here in the pool, that does affect the probability negatively. When you yeah. So I want to put it into proper context here with the numbers that you're looking at here. So yeah, with that one little extra less that you have in the pool because you're not replacing, that does affect the probability here negatively. Okay. With so that affects the probability here negatively if you added it back. So with more possibilities means a lower probability. With less possibilities means a higher probability here. So as you can see. Where's the less possibilities here? We had a 7 out of 12. So that's why the probability here is lower than that of the counterpart here. And the same thing for letter A. We actually have a higher probability for letter A because we have a lower number of possibilities here for our second one. So yeah, hopefully that answers that question there. All right. Any more questions? Any questions? Any more questions? Any more questions? Guys got? Nope. All right. Okay. Alrighty. Good stuff. Okay. Thank you. Not yet? All right. Yes, that is the end here. So I want to thank everybody for coming on out here today. I appreciate all of you. All right. Thank you so much for coming out here to this class here for today. I'm going to be on back in about, I don't know, 12 minutes for the second class. But in any case, if you guys are heading off, please enjoy your weekend. Have yourself a wonderful day. All right. Everyone take care of yourselves. Remember, stay safe, stay healthy, and most importantly, everybody, stay sane. All right. We will see you next week. All right. On Monday. All right. Again, remember that the test was extended until tomorrow, so be sure to finish it by tomorrow, okay? And the homework as well. All right? Okay, everybody. Have yourself a wonderful day. We'll see you later. All right, everybody. Take care, and you have yourself a good one. I'll be right back. All right. For those of you leaving, bye. start here a bit early with a little bit of hellos. Yes. Hello, everybody. Hopefully, everybody's doing well. Hello. Let's check out stuff here. Just 18. How's everybody doing today? I hope everybody's doing really, really well. You're here in chat having a nice time. Man, already good vibes today. Good vibes from people. It's gonna be another fun one. I just know it. Hey, it's Madison Hazelnut. Hello, happy Wednesday. That is true. Happy Wednesday, Madison. You're in a good mood. I'm very happy. Thank you, Hazelnut. Hello. How have your days been already? I hope they've been very good. This afternoon, we're already Wednesday. I can't believe it. I can't believe it. It's already Wednesday. My goodness. Already made it to Wednesday? That was fast. How you guys doing today? I hope you're doing well. Hopefully everybody's been pretty chill. See here. Oh, here we go. Starbucks this morning. Woo. Ashley Vance, good afternoon to you. I hope you're doing very well. Starbucks, man, I got a good drink by me today that I got in the first class here. I got this yesterday at Mitsuwa, so I got a shake up this drink here. Bottom there. There we go. All right. I got today I got this yogurt drink. Okay, today I have this yogurt drink. It's Gurt. Non-carbonated yogurt drink. Yeah. Gun Gert. Yes. I hope the yogurt wouldn't be carbonated. That's true. This is a really good drink, though. This is it goes down pretty smooth. Despite it being a yogurt drinks, I know sometimes can go a little rough, but yes, this one here goes down pretty smooth. So not the smoothest, of course, because yogurt's not the most smoothest of things, but still does a pretty good job. I ain't gonna lie, does a pretty good job. Woo! Got a good class for today. I know everybody's pretty excited. Maybe they have a good class involved. All right, I see some more people joining the chat. This is positive. Positive. I like where this is going. I like where things are going. It's good. It's good. Where are we going today? Hello? Really? The train, it doesn't stop. It just decides to keep going. Interesting. Interesting. Hey, JD, how are you? Are you doing well, my friend? How we doing today? This afternoon, I should say. I always keep thinking it's like morning, but it's this afternoon. Keep thinking, it's like this afternoon. What are we talking about here? Like, oh, yeah, it is afternoon. A little bit half past, but you know what? Still counts. You got X-rays done? Oh no. On what? Would you have X-rays? You messed up your hand. Oh no. Oh no. What happened? What happened there, JD? How'd we mess up our hand? That's not fun. The left hand had no idea, just stopped working. Did you like sleep on it wrong, where you kind of bent it, kind of backwards or something like that? Loud. Maybe. Yeah, I've done that before where I threw up my neck and back because I just slept on it wrong. Like, you have no idea, but you're sleeping at an angle sometimes, and then you just your muscles just kind of atrophy in, like, one direction or something like that. I know that's happened to me before. I know that's happened to me before. So, hopefully you'll feel better once you figure out what's going on with your hand there. As that's a little bit concerning, I must say. I ain't gonna lie. Yeah, you do that. Tendon is swollen. Ooh. Ooh. Yeah, that doesn't feel good if the tendon is swollen, right? That's true. Well, I would assume it's a pain. It's pretty painful. Question mark, question mark, question mark. Quickly do this. I'll take that. Good beans. All right. All right. All right. Who's ready for some? Who's ready for some fun? I'm ready for some fun. I hope you are too. Okay, let's do this. Been like that for a month. Ooh, that's not good. That's not good at all. Well, let's see if some math, not mentally, but physically, I guess. Fair enough. All right, let's do this. Let's do the intro here. Let's get things done. Oof, a month, yucko. All right, anyway. This. Okay, let's get started today. Welcome back. Welcome back to Wednesday, end of the week time today. So today we're going to continue moving forward here from where we left off last time. Last time we talked about section 5.3. Okay, we went ahead talk about our talked about a couple of probability rules from last time here, such as we talked about addition, we talked about ands last time there. Okay, how we were able to use the rule of complements as well. So we did talk about the words at least, so we're going to continue where we left off there from last time, and we're going to continue moving forward. This shouldn't be overtly too bad. Again, it just takes a little bit of getting used to, but today we're going to be taking a look at a few things. So let's get up the handout here first and foremost. Go to here. Yeah, screen out. Okay. There's the main screen here for section 5.4. All right, so really quick here, I'm gonna do a quick poll here for you guys in class. I asked the first class this, and I want to ask you guys this as well. Is that we did Discord here last time? Okay, so we did a little bit of stuff here with Discord. I know some of you really liked it with just asking me questions and whatnot. So I'll put up a poll here for like a minute, just a quick minute poll here. You guys vote. Did you guys like the Discord part there? You put yay or nay. All right. If you like the Discord part there, I will do more in the future. Okay, so we could talk and then you guys can ask me questions and whatnot. So um, so sometimes a little bit of group work isn't too bad. But I just want to get your feelings about it. That's all. We'll have a few more seconds here, then we'll. You like the group work? To be honest, okay, that's very fair. That's very fair. Yeah, look, yeah, we're not a super big class, so All right, so a majority of you voted yay. Okay, so we'll be doing a little bit more group work in the future. Um, again, it won't be like every single class. Okay, mind you, it'll be some classes, but not every class. Okay, so just understand that. Okay, so yeah, there'll be times for something like that, and there'll be times for other things, I'm sure. All right. Well, that sounds pretty good to me. All right, thank you for the feedback there. I really appreciate it. All right, so I just sometimes I may ask you for your feedback there, just see exactly where you guys are at. But yeah, sometimes we'll do it, sometimes we won't. Just depends. All right. So let's take a good look here at section 5.4. All right, so what are we going to be doing here today? Today, we're going to be talking about computing conditional probabilities. Okay, so that's one of the things that's on the docket here. And we'll be computing probabilities using the general multiplication rule as well. Okay, so that's going to be what the main focus is for today's section. So let's go ahead and talk about it. Let's discuss things, and let's see how things work. We'll have good times, good beans, good everything. All right, let's look at number 3 from the handout here. So this is a continuation from the handout from last time. So if you have the handout from last time here, this is question number 3 on that handout from last time, okay? All right, so question 3. What is a conditional probability and what is its notation? So the formal definition here for a conditional probability is the conditional probability is the probability of one event B given that an event A has occurred. So we're given a condition event A, okay, and we want to find the probability of event letter B, okay? So they're going to be two separate events that are going to be happening here in these conditional probabilities. One of them was going to be the condition, and then one of them is the actual probability we want to associate with that given condition put on top of it. Okay, so what I want you to look at here is I want you to look at the notation that we have here. So the notation that we have here says probability of B with the big line here and A. So this is the way we read this is the probability of B given with the line here, A. And that's how we read this from left to right, okay? We say the probability of B given, again, the word given here with the line here, A. So event A there, all right? So one of the key things that we're going to focus on here is, I'll note this here. So one of the big keys that we can focus on here is that read the probability from left to right, okay? So read the probability with the notation and put in mind, read the probability from left to right, again, with the given condition here. Okay, so the probability of some event given this event, or given this event, okay, you have this event happening, so it'd still be the same thing as probability of this event given this event, just written in slightly different order. But so read very carefully there. Be sure you get that down. We're going to take a look at some examples here. But before we do that, we have to actually acknowledge how we can compute conditional probability here from a generic perspective. So the way we want to look at this here is we say, okay, how do we compute conditional probability? Well, the probability of B given A is the probability of A and B divided by the probability of A, which equals the number of A and B divided by the number of A. Now, one of the things that I talked about here earlier is I said, hey, I'm going to put this in both notational format. Okay, so I'm going to put this in both notation and I'm going to put it in words. So as you can see down here, you have it here directly in words. Okay, and with words, again, you can see how both of them line up and exactly what each part means. So again, we will be using this definition here. Uh, just we'll be using this definition here, just maybe not in the order that it kind of necessarily puts it in, but you'll see exactly what I'm talking about here. One of the most important things here, I have two notes here that I do want to point out here. First of all, um, the probability of B given A is not going to equal the probability of A given B. So one of the most important things is that B given A and A given B, the probabilities of both do not equal each other. They are two separate probabilities. They're two separate conditions because one gives a condition of A and the other gives a condition of B. So off that little note there, the other note that I think is important is that order matters. Okay, order is going to matter significantly because one of those events is going to be our condition and one of those is, excuse me, oof, man, I gotta stop doing that. One of them is their condition, and then one of them is going to be our actual probability that we want to test over. So we're going to look at those. Okay. So let's do an example with actual numbers, okay? And let's see how we can compute some of these probabilities here together. Okay. All right. So, right. Okay. Okay, so the first thing that we're going to look at here is we're going to look at number 17 here, okay, on the screen. So number 17, as you see here on the screen, this is something that we'll talk about here more in chapter 4. Okay, in chapter 4, we're going to talk about contingency tables in a little bit more detail, but we can use these contingency tables now in order to figure out some conditional probabilities. So let's take a look at that and see what we're working with. All right. Okay, so number 17 says, in a recent Harris poll, a random sample of adult Americans 18 years and older was asked, when you see an ad emphasizing the products made in America, are you more likely to buy it, less likely to buy it, neither more nor less likely to buy it? And of course, here are the results that you see here on this contingency table. So we have some categories here, okay, on each of the for each column and each row. Okay, so we're associating just two sets of data with each other, something that's not so hard. Okay, in any case, let's take a good look here at 17, and we say, okay, well, what's the likelihood that we're going to buy it or not buy it? Okay, again, we don't know, but again, we're going to find out. Okay, so let's take a look at each part here. Go over the first part here. Now I'm going to read this part off here because it's on the next page, but nevertheless important. So it says, what is the probability that a randomly selected individual is 35 to 44 years of age, given that the individual is more likely to buy a product emphasized made in America? So in this case here, we're going to give 35 to 44, given that you're more likely to buy. Okay? The probability of 35 to 44, given you're more likely to buy. All right. So let's go over each part here and how I actually compute this out. Now, the first thing is that we're underneath a limited window when it comes to conditional probabilities. So the first thing I'm going to look at here is I'm going to look at my given condition. So right here, more likely is my given condition. So I first look and I say, all right, well, how many people are in the more likely category? Well, according to our table here, the number of people in the more likely category is going to be 1,329. I'm actually going to figure out that first. It says, okay, I have 1,329 people with this particular condition that they're in the more likely category. Now I have to ask myself and say, okay, well, how many of them in the more likely category are between the ages of 35 to 44 according to our table? Well, according to our table there, that happens to be 329. We're in the more likely category and again in the 35 to 44. So within just that small window of more likely, how many of them were 35 to 44? Well, 329 of them happen to be between 39 and 44. So here in this case, here we get 2476, okay, if we look at our decimals here. And that's how we're going to be able to find our answer for part A. Okay, just kind of showcasing that out there. That, hey, here you go. Okay, yeah. So I always find out exactly what window I'm trying to find, how many numbers I have. Like I have 1,329. So out of that 1,329, how many of them fall within that category are actual 35 to 44? Okay, well that happens to be 329. Okay, and so that's how we can basically tackle these type of problems. All right. Now, one of the things that I do want to point out here is that oftentimes the biggest mistake people make in these problems is getting a probability that is more than one. Sometimes they'll flip around the numbers. So that's why I do the bottom number first instead of the top number. That way I know that I'm going to get a probability that's between 0 and 1. If you get an answer that's above 1, you know you put the numbers in the wrong places or you know you're working with the incorrect numbers and you might want to start again. So you should never get a probability above 1. Again, probabilities are only between 0 and 100%. If you get anything above 1, it makes no sense to have 150% probability. That doesn't make any sense at all. Okay, so be sure you're not putting those numbers in the incorrect places. Okay, well, let's take a look at the next question then. And this time I want you guys to try it here. Guide this together here. So what's the probability of, let's reverse things around here. So the probability of more likely given that the people are 35 to 44. Probability of more likely given 35 to 44. So let's go in order here. Okay. So if you guys answer this question here really quick, our given condition here is 35 to 44. So that's what we're going to look at first. How many people are in the category, according to the table here, how many people are in the category 35 to 44? How many people are in the category 35 to 44? Hey, Sammy. Sammy Jane, how are you? I hope you're doing well. Wonderful to see you. 536, right? Okay, so that's correct. We have 536. Oh, absolutely. You know you're welcome in here anytime, Sammy. Anytime. It's wonderful just to have you grace us with your presence. I think it makes the stream even that much better. As I told you before, Sammy, you bring a lot of good positive vibes to many communities. I really respect that about you. All right. So we have 536 people from 35 to 44. Never underestimate yourself, Sammy, by the way. You are one of the kindest people you're one of the kindest people I've had a chance to talk to. So, appreciate it. What you do is just as good, okay? We're equals here, Sammy. We're equals here. You do wonderful things for a lot of other people as well. Look at how much joy you bring to people, on Fobs' stream. Yeah, look at how you look, look at you know, even if the days you're feeling meh, you still have a good smile on your face. So, I mean, I don't bring a ton to the table here. It's just, everybody else brings it to me. Everybody else here supports a lot about what I do, and you're definitely one of them. I'm just like I said, we had a chance to talk. Um, you had a very, you know, yeah, you're very, very positive. I really like that. Like, I could just see if we met in person, be like, hey, you just sit and chill and stuff. It's all good. Sammy, oh, you didn't have to do that, Sammy. Oh, no, 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 no. You didn't have to do that. Oh, I appreciate it, Sammy. Sammy Jane. Thank you for the sub. Oh man. Oh man. You didn't have to do that, Sammy. Oh goodness. Oh my goodness. Woo. All right. I appreciate that, Sammy. You're super kind. Yeah, it's more than what I deserve, you know. More than what I deserve. You have Sammy Jane, you bring a lot of good people together. You bring a lot of good people together, Sammy Jane. Okay. So you have value, and if nobody else on planet Earth recognizes the value that you bring, well, this I will be the one person who can tell you you have a lot of value, a lot of good value that you bring to the planet Earth, for sure, Sammy Jane. Okay. So anytime you feel down, anytime you feel like things are kind of meh, remember, remember, there is one person in this world who will absolutely 100% believe in you, and who definitely knows that you bring a lot of value to a lot of different people. Give yourself a pat on the back. Give yourself a lot of credit. You you earned it. You earned it. You so yes. Uh Wish it wasn't so cold in here. All right. Yeah, yeah. That's what I think. So yeah, I don't speak words if I didn't believe it. So that's how it rolls. Yes. All right. Sorry about that. That kind of it's one of those things I wanted to say. So to you, Sammy. So, oh, I appreciate that, Sammy. You know, if you told me that you told me that like 5, 6, 7 years ago, I probably just brush it off and be like, I don't deserve it. I don't deserve anything. No. Now I could actually say I can appreciate that, and I could actually think about that. I used to have I used to have very low confidence about myself a long time ago. And slowly but surely, I've kind of built it up over time. And I meet a lot of wonderful people. All the students in this class and in all my classes. Uh, you know, I met you. I've met the communities in many different channels here on Twitch. Online. I friends I go see. Offline as well. Uh, a lot of people have built me up over time. Saved me from certain situations. Um, yeah, sometimes I'm like, how did I make steps to even get to this point? And I'm really happy that I made it. I'm really happy that I made it, and that it wasn't just me, but everybody gave me a lot of good vibes and positive vibes and confidence to be the person that I am. I'm not the richest dude on the planet. Um, I'm not the greatest thing since sliced bread. I'm not even the strongest dude on the planet. I got more fat on my arm than I have on I have more fat on my arm than I actually have. Okay, no, I have maybe more fat in my head, but anyway. But yeah, there's a lot of people who brought me to this point. A lot of people who brought me to this point, and that's why I give them more appreciation. Uh, but now I can say with a certain bit of confidence that I appreciate all that you do as well, and I appreciate your kind words to me and your compliments. So I can say that with a degree of confidence compared to what I was 5, 6 years ago. So that's for sure. Moo indeed, JD Moo. That's true. That's true. A lot of moos, a lot of nays. Ah, why is my nose so runny today? Okay. All right. Um. Right. Okay. Yes, I'm supposed to be doing this. All right. Yes. How many people in the 35 to 44 category are more likely? Let's talk about that. How many people in the 35 to 44 category are more likely, according to our table? Yusuf says to hydrate. All right. Got a yogurt drink here today, Yusuf. Today is yogurt drink day. Double hydration. Madness. Go, my friend. So how many? Oh my gosh! All right. He's such a troll. You're such a troll. Hydrate or titrate. Well, if I continue to hydrate more, I'm just going to have osmosis all over my body. It's just going to start coming out in droves. I'm just going to be honest with you. I'd be like, smells like yogurt. You have 4K points to save so you can hydrate. That's fair, Ashley. Use of my day has been going very well. Very, very well. Look at all these wonderful people in the chat. That's why my day is going well, because of the many wonderful people I get to talk to all the time. 1,329. So so JD here. Let's answer this one more time here. How many people are more likely? How many people are more likely in the 35 to 44 category? So if you read the question carefully here, how many people are more likely? Yes. Okay, very good. That is correct. Hey, Connor, how you doing, my friend? So we have 329. So I want you to take a look at what I did here. Okay. I want you to take a look at what I did here. We have a 329 out of 536. So that's essentially what we did here. I'm doing good, my friend. I'm doing wonderful. Really good, actually. This is a good. So what we did is we did the conditional probability formula here. We did the probability of A and B divided by the probability of A, or again the number of A and B divided by the number A. So the number of guys in the 35 to 44 category was 536, and the number of people that were both in the more likely category and the 35 to 44 category was indeed 329 here, according to our table, as we can see here. Okay, so we just go ahead and figure out what we get here. So we take 329 divided by 536. So we get 0.6138. 0.6138 is what we get here for our final answer for this problem. Okay. Well, let's take a look at another example here using the same table here. So this time I want you guys to give it a shot. I'm going to make one up on my own here. Let's do the probability of neither given 55 plus. So the probability of neither given 55 plus. So let's take a minute here. See if you guys can get this one here. The probability of neither given 55 plus. Got JD puts 118 over 536. Okay. All right. Let's see some other answers here. I'll see if that's we'll find out if that's right here. Okay, so that possibly could be right there. Let's got that. Okay. See some other answers here. $188 over 536. We get the. Oh, okay, okay. You just mistyped there. All right, that's fine. Any other answers? Any other answers we got here? Go ahead and just type them out. That's perfectly fine. Okay, well, let's take a look here at some of these answers here. So 0.2201. Okay, well, let's take a look and see if these answers here are correct. All right, first of all, we're given the condition here that we are in the 55 plus category. So how many people are in the 55 plus category? Well, according to the table here, that happens to be 536. So that's the pool of people we're going to be looking over, 536. And we say, well, how many of them are neither? Okay, how many of them are neither? Well, in the 55 plus category, how many people are neither in that 55 plus category? Well, that happens to be 118. So 118 people are neither and in the 55 plus category. So we then go ahead and do this out. Okay, and indeed, our final answer here will be 0.2201. So again, just go steps in order here. Let's go in order. Okay, so very important here. Just make sure to go in order here. So again, how many people are in the given category? Okay, so how many people in the given category or the given condition? In this case, there were 536 people in the 55 plus category. Well, out of those 536 people, how many people were in the neither category? Well, out of those 536 people, 118 were neither. That's why we get 118 over 536. So one of the things that I want to point out here specifically is that to take these problems fairly slow, okay, make sure to just do it one piece at a time. Figure out what the pool of people are, or how many people you got, and then you're going to take it out of that amount. You know that amount has to be lower than that if it's going to be a proper probability. So one thing you could take to the bank there. So again, always start with your given condition first. Okay, so always start with this second guy here. This is what you should do first. And then you should figure out this part here, which should be second, after you apply your given condition. Okay. Any questions? Any questions about that? Want to be sure everybody's pretty clear about that part in particular. Nope. Okay. Okay. I'm gonna have you guys do nay, nay indeed. Okay, so I'm going to have you guys try a couple of problems here. Now, these couple of problems here are from an old test of mine. So this would be like a test question I would actually give you. But this is a sorry, an extremely valid question nonetheless. I'm going to go over here. This is actually from one of my tests from back in the day replay. All right. So we're going to do two specific parts here. We're going to do parts C and D. So you don't have to worry about A or B here, but please do parts C and D, okay? So so here's the question here. Bureau of Labor Statistics, and then some numbers there. So let's do parts C and D there. I'm going to give you a couple of minutes. So I'll give a couple of minutes. So I'll have you, and we will answer the question. So let's go ahead and give these a try. I'll come back in a couple of minutes and we'll give it a try. Okay. I want you to see if you guys can get these first though before we talk it over. Let's give it a go first. My face is, oh, sorry about that, Hazelnut. How's that? Is that a little bit better? There you go. There you go, Hazelnut. That should be a bit better there. Now that my face is not in the way. Let's see how it goes. Take another so. See how it goes. Uh, so yes, JD, 4 decimal places as usual. Okay. All right. Okay, so let's see what we got here for letters C and D here, respectively. All right, so we're going to do this out here together. It's over here. All right. time I've done that. All right. Try that again. Okay, let's go to letter C here. So, given that the person is a female, what's the probability that she has a management job? So in this case here, we want to find the probability of a management job. That is management job, given that it's a female. All right. So, what did we get here? Probability that we get a management job given that it's a female. What did you guys get? What did we get for part C? What did you get for part C? All right. Got 25. Got Abraham Lincoln for some reason. I can't even answer that. 25.8 over 64 and a half. Okay. All right. Any other answers here? Yeah, 0.4. Okay. So let's take a good look here. We first want to figure out how many females we have. In this case here, that's correct. If you went over 1, then you know you put your numbers in the wrong places. That's right, Hazelnut. That's why I have the note there, because that's a most common mistake I see in these problems, is putting those numbers in correctly. Remember, start with the denominator first and then do the numerator. So if you're doing the denominator first, then the denominator will be your given condition here, your pool of people. So we have to say, well, how many females do we have here? We have 64.5 million women according to this survey here. And how many of them have a management job of the women? Well, 25.8 million of them have a management job. I thought this was science. Oh boy. All right, so if we do this out here, 64.5, and indeed we get 0.4. That is correct. All right, so that's correct here. We get 0.4 as our answer for letter C. Okay. Hopefully that gives you a little bit of inspiration here for letter D. What did we get for letter D? Given that a person has a management job, okay, so given that a person has a management job, what is the probability that the person is female? So we reverse things around here. So we're given on the probability of a female given a management job. $25.8 over 50.8. That is correct. Very good. That's right. So here, yep, I totally agree. Well, wait, 0.4624, is that below? Is that below 50%? I think that may be a little bit low. So let's find out. Let's find out. Forgot what the decimal was off the top of my head. In any case, um, we have how many people have management jobs? Well, we have 25.8 million plus 25 million. Okay, between the two, between male and female here, according to the survey, 25.8 million women had the management jobs, and then another 25 million from the males as well. I'm going to add those two together because those are the total number of management jobs according to this particular survey. So 50.8 is correct. Well, how many of them were female? according to this here, 25.8 million out of the 58.8 million are women. So that's where we're going to come up with this right here. 25.8 divided by 50.8. And here we get 0.5079. Oh, okay. That's what happened. You just accidentally put 55. All right. That's fine. Yeah. It's one of those small things. As long as you got it consistent, the other number's consistent. Yeah, that's fine. Not a problem. The process here is more important here, so definitely one of those things that we want to look at here carefully. 1000% true. That's okay. I mean, your eyes are probably better than mine anyway, Planet. Like, let's be honest here. My eyes are the most abysmal things. They're pretty bad. Okay. Any questions about that? Any questions? We're gonna move on here if there are no questions. I just want to be sure. So I have minus 12 and minus 12.75. My glasses literally cost me 800 bucks. You'd rather ask over Discord than my. Okay, that's fine. That's fine. We can talk after class there, Hazelnut. I don't have a problem with that. Most important, the most expensive thing I ever wear, my glasses. All right. Okay. Got to move on here to the next part, though. That's kind of important. All right. So we're going to look at the last couple of questions here on the handout. So let's look at that right now. Oops. Here we go. So let's look at the last couple questions here. So let's look at question 5 here. What is the general multiplication rule? Well, basically, the general multiplication rule is just an extension. Basically, oof, that's rough. I ain't gonna lie. The general multiplication rule is just an extension off of what we talked about here at number 4. If you want to find the probability of A and B, all you really have to do is multiply by the probability of A on both sides, and then essentially you get the probability of A and B is equal to the probability of A times the probability of B given A. So you just multiply by probability of A on both sides, and then this is essentially what you get. Now, the way we're going to apply this general multiplication rule, though, is we're going to apply it in a couple of particular circumstances. So although it doesn't look like we directly use this, we're going to brute force our way to essentially using this here in some form or fashion. And the way we want to do that here specifically is, let's zoom in once again, is we're going to talk about with or without replacement. So the way where we use this is we talk about sampling with or without replacement. So with replacement here is fairly simple. All right. So with replacement here means we replace the item back. So meaning to say, if we have a deck of cards, so there's 52 cards in the deck, and somebody asks us, okay, pull out a card from the deck, and we look at the card or whatever, we place the card back in the deck. Well, there's still 52 cards in the deck, okay? I took one out, but then I put it back in. So I still have the same 52 cards in the deck that I had from before. Without replacement, I don't put it back. So I have the deck of 52 cards. I go ahead and take one out of the deck, but this time I don't put it back. I put it off to the side or whatever. And now instead of 52 cards, I have 51 cards in the deck here. And I can do that, of course, as long as I'm putting the card I pull out to the side. I'll have X amount of cards off to the side for that many pulls and however many cards are left in the deck. So again, if I took out 2 cards, I'll have 50 cards left in the deck to do whatever. Okay. Now, one of the things that we talked about here last time is we had to watch out for some keywords. Okay. And that keywords there, again, specifically being such as at least or exactly. Okay, so such as at least or exactly. All right, and we talk about at least or exactly probabilities must be done differently. Okay, so that's the one thing that we have to be very careful about is we always have to be careful about the words at least. Remember we said that involves multiple cases, okay, depending on how far up we go up the ladder, or exactly means just that one particular case. So at least multiple cases, exactly means typically just exactly means one case and one case only. Everything from Walmart, but it'd be $1,000. Yeah, that's probably right. My glasses I got like 10 years ago, so I don't know how much it would cost now. It'll probably be around that price. So, um, okay, now let's take a good look at an example here together. Okay, and I want you to go ahead and we're going to go ahead and answer these together here. Hey, I like having four eyes. It means I can see you. Means I can see you doing things and call you out a whole lot better. Just saying. Um, all right. I know you're kidding. I'm kidding too. I don't call you out all the time, JD. That's how it works in class. Okay, so the question we're going to look at here is oh, that's cool. Yeah, mine's so basically how it works here is that for me when I was younger, for glasses and whatnot, I had to get them replaced like every few years because the more you grow, I have macular degeneration, just by genetics and whatnot, because both my parents had pretty poor eyesight. So, but after you get toward a certain age, it starts to slow down significantly. That kind of degeneration, it starts to slow down quite a bit. So, you don't need glasses as often once you pass like 30. So, but yeah, up to like until I was like 20, up I was to like 25, I would be getting glasses every first of all, it was like every 2 years, and then it was like every 3, 4 years, every 5 years, and then I got this pair when I came back from Japan at the age of like 30. So I was like, and that's the last pair that I gotten because the degeneration has slowed down enough where I don't need to get it so often. So yeah, there is definitely hope. It's just a matter of your body continues to grow until a certain point, and then when it stops, then that kind of degeneration is not going to be as prominent. So yeah, that's something to be aware about is that yeah, it's just a matter of when you stop growing. And typically that's around the age from 25 to 30 is that you pretty much have stopped at that point. So I mean, obviously there are rare exceptions. There are exceptions to the rule, right? I mean, obviously, but for most people it works out that way. Yeah, yeah, yeah. I want to keep growing. I'm short. One of my pictures from way back when is I used to be really short. In high school, I was 5 foot nothing. So I didn't actually start growing until my after my freshman year of college. Yeah, when I was an undergrad. So it wasn't until I was like 18 when I actually started growing from 5 foot nothing to being 5'10". So yeah, yeah. If sometimes the body waits and the thyroid acts up afterwards. Like okay, it is what it is. So for me, it happened really late. So maybe the same thing applies to you as well. All right, ladies and gentlemen, let's look at 27. Oh my goodness! Hey, Ninja, how you doing, my friend? You heard this where I learn math good? Yes, this is the place, my friend. This is the place where you learn math good. We're learning some statistics here. Maybe you can answer some questions along with us. That's perfectly fine. Let's do this, right? Let's look at 27. It's good to see you, buddy. Good to see you. You're always welcome in here, by the way. Um, uh, all right, so number 27. Suppose that a digital music player has 13 tracks. After listening to all the songs, you decide that you like 5 of them. With the random feature on your player, each of the 13 songs is played once in random order. Find the probability that among the first 2 songs played, that A, you like both of them. Now we're going to break this down into 2 parts here. All right, so you listen to the CD or you listen to the record or you listen to the digital player, whatever old school methods or new school methods you use, doesn't matter. But let's say again, you don't have true RNG. You have, say, all right, 5 of the songs you like here, and the other 8 here, there's 8 more songs here you dislike. Because, like every album that comes out, there's going to be some songs that you like, and there's going to be some songs you just don't like. Because that's just how it is. I've only heard one album that I felt I liked the entire album. So, yeah, there's very few albums where you're going to like every song. So, that's my personal taste. Anyway, in any case, there's 5 that you like, 8 that you dislike here. Now, we have 2 songs that we play. Which album? The first ever NSYNC album. Back in the day when boy bands were crazy. I actually listened to the first NSYNC album. The whole album was actually really darn good. I have to respect the process. Was a very, very good. Was probably the only CD that was ever worth buying because of how good every track was on that CD. I can't deny how actually really good every song was. I can't deny it. Was very, very well done. 100%. Uh, original instinct, go figure. All right. So let's take a look here at both these cases here. So it says, all right, what is what's the probability that we like? That's okay. If you listen to the first NSYNC CD, uh, first NSYNC album like ever, which is just a self-titled album, NSYNC. Um, yeah, it's pretty outstanding. In my opinion, probably one of the best probably one of the best albums I've listened to for a boy band. Um, okay, so let's take a look at letter A. We like both of these songs here, so we're going to take both songs into account. Okay, we like the first one, so somehow, in some way, we like the first one and we like the second one. Now remember how this is going to work here. All right, specifically. It's specifically one of the most important parts here in this question. It says each of the 13 songs is played once in random order. So there is randomness to this, but again, once we play one song, that song won't come up again until all the other songs have been played. Okay? So in this case here, with this very key sentence, this is basically without replacement. Okay? So we're not replacing the songs here because once they're played, that's it. Okay? Then it's not in the pool anymore. Okay, it won't come up again until all the rest of the songs have been played in some random order. So let's take a look here at the first song. Now let's say if the first song we like, what are the odds that we like the first song here? What are the odds that we like the first song here? Anybody tell me here? Say we like 5 of them, we dislike 8 of them. Okay. What are the odds that we like the first song for this first song? Now, not 1 out of 5. 3 to 1, I don't know. Well, how many songs are there that we like? How many songs are we have? We have 5 of the songs. We have 5 songs we like, right? Ah, there you go. Very good. So we have 5 songs we like out of the 13 total. There's 13 total songs that we can select from the pool. 5 of those songs are songs that we like. So, since it's the very first song being selected, then it's going to be 5 out of 13. That's right. I think in gambling terms, yeah. Your odds are a little bit better with the gambling terms, I'm going to be honest. 5 out of 13 is better than 3 to 1. What about the second song go? So you listen to the first song, you like that first song, okay? But now that song is no longer in the pool, all right? So that song can't come back until we play all the other ones. So what's the odds that we like the second song now? What are the odds we like the second song now? Ooh, that's close. That's close, JD. That's very close. So I agree with 4, right? Because that song's now no longer in the pool, right? Now we have 4 songs we like. Ah, yes, very good. But remember, by taking away that song, you took away one song from the pool simultaneously, so you actually have correct 4 out of 12 because we're not replacing that first song, which means now we have less choices. So we have 4 out of 12, 4 out of the 12 songs we actually like that's left in the pool. And all we have to do now is then multiply those two together, and then we're going to come up with an answer. So let's go ahead and see what we get here. So in this case here, we are going to get 0.1282 as our final result here for our decimal equivalent. And there we are. Easy enough, not too bad. Okay, so far so bueno. So far so bueno. All right, let's look at letter B. All right, let's take a look here at letter B. Letter B says, what is the probability that we like neither of them? So we like neither. So again, so the numbers keep diminishing. Yes, because we are not replacing, right? Because of no replacement. That is why. So remember, with replacement, the amount of numbers in the pool would not diminish. But without replacement, well, then they do. So that's why that's happening there in that problem planet the way it is. Let's take a look at this next one here. What if you dislike both? So it's like, okay, I don't like either of these songs here. Both these songs are kind of smelly. So, okay. What would be the odds that the first song that I play, I would dislike? What are those odds? The odds that I play, I would dislike those. What do you guys think? First song I play, dislike. 8 out of 13, that's right. Okay, that's good. So 8 out of 13. I had 8 choices I didn't like out of the 13 songs. Fair. All right, play the second song. I don't like that one either. What are my odds now for the second song I dislike? What are those odds now for the second song? Remember, I'm not replacing the song back into the pool, so 7 out of 12. That is correct. Yes. 7 out of 12. That is 100% correct. Very nice. Right? Because we didn't replace the song that we disliked the first go around, and there's one less song in the pool. Very good. Nice. Okay, so we have 8 out of 13, 7 out of 12, and we got 3590. All right, good stuff. Nice job. All right. Okay, so that one's not too bad. All right, not too bad at all. Okay, now let's look at letter C. Okay, Now, letter C here is a little bit different than the first two because letter C says we like exactly one of them. Okay, so the probability of we like exactly one of them. So like exactly one of them. Now, the key word here in this case is the word exactly. Okay, now we're still going to do this without replacement. That part is true. But in this case here, we can end up here with one of two possibilities. Okay, so we have two possibilities here that can happen underneath this scenario because we play two songs here. So in the first two songs, we have to have exactly one be the one that we like. So it could happen that the first song we like, but the second song we dislike, or the first song we dislike and the second song that we like. Okay, so we have two individual cases. Okay, first song we like, second song dislike, or the other way around, first song dislike, second song like. In either case, both of those have to be taken into account. So let's see what we get here when we take into account. Now again, let's just write out the scenarios here because we're going to add up these two guys here together. So we're going to have, again, I will write like and then dislike. Or again, we could write dislike and like. Alrighty. So let's take a look there. The first thing. So how about like? Let's go with the first case here. What is the odds of liking a song here? Liking the first song. Remember, it has to be exactly one. So these are the two cases where exactly one happens. What are the odds for exactly like here? For this first song here. 1 out of 13? How many songs do we like? Let's just take a look here. No, let's again use the same thing that we had before. We're still underneath the same premise here. We have 5 songs we like, we have 8 songs we dislike. So we're still underneath the idea that we have 5 out of 13. Okay? Don't think that anything changes just because it says the word exactly one. We're going to approach it the same way we did the last two parts, only we just have two different cases to get exactly one. See, notice I have one song in either one here that we exactly like one. So either the first song we like, second song dislike, or vice versa. That still satisfies the condition of liking exactly one. Liking exactly one does not reflect 1 out of the 13 songs we like. That is not what it's asking us to do. So if you're getting confused between the two, it's really asking us, out of the pool of songs that already exist, with the 5 like and 8 dislike, what would happen if we exactly like one of those songs from the first two songs that we play? Okay, so don't get confused about the wording here. What they're talking about is already the intended scenario that we have up top here. Okay, how about the next one here? So we like the first song here. What are the odds we dislike the second song? What are the odds, without replacement here, what are the odds that we dislike the second song? What is that? 7 out of 12. Okay, be a little careful here, Planet. We dislike this song. How many songs do we dislike? We the first song we liked. Okay, so that's fine. How many songs we dislike? Yes, 8 out of 12. Right. So I agree with the 12 part here. That part's correct, Planet. But remember, we still have 8 songs left in the pool that we dislike because the first song was the song that we liked. Okay, so that means we didn't remove any dislikes. Okay, so 5 out of 13 and then 8 out of 12. Again, we got a song we dislike there. There are 8 songs we dislike, and there's 12 songs remaining left in the pool. Before I move on here, are there any questions about that? Are there any questions about that? I want to be sure that you guys understand why are we adding? We're adding here because we have two separate cases to get exactly one, JD. Either you like the first one and dislike the second one, or flip it around. You dislike the first one and like the second one. So they're two separate independent cases to get exactly one that we like. That's why we're adding both of these cases here together. So when we talk about separate independent cases, we're going to add together. All right. All right. So let's take a look here at this one here. What about disliking here? What are the odds that we dislike? So this is a separate case now. That's correct. So like when we talked about adding, when we talked about, sorry, not adding, sorry, Planet. When we talked about at least, we were actually adding all those cases together. When we said like at least one, we were taking probability of 1, probability of 2, probability of 3, probability of 4, probability of 5. We were actually adding all those cases together because they were all separate independent cases, but they reflected at least one, for example, like we did in the last section. 8 over 13 and 5 over 12. That is correct. Yes, 8 over 13 here for dislike and 5 over 12 here for liking the second song. Okay. That is correct. So all we have to do here is add these two together. So 5128. Okay. Now, very good. Now, there is another part here that I haven't talked about just quite yet, but I can take like a minute since we don't have a lot of time here, but still, let's take a little bit of time here. So, what would happen if we changed it with replacement? So let's say it was true RNG, okay, truly randomly generated, okay, meaning to say we played a song, it can get put back into the pool again, all right, it can get put back into the pool of songs there, and it could possibly be repeated a second time in a row. That's certainly possible. So if I did it with replacement here, for example, let's say I did letter A here with replacement, unlike the actual example here. Uh, if we did like and like once again. In this case here, with replacement, we have the first song that we like would be 5 out of the 13 chance of getting a song that we like. The second song, let's say we did the second song here, the second song we like also is the same 5 out of 13 chance. Remember, nothing changes, okay? Nothing changes with replacement. You still have the same pool of songs and the same amount of songs that you like here because it can just be put back and the situation doesn't change. So you get 5 out of 13 and 5 out of 13 here. And then you go ahead and do it out. And we get 0.1479. So you can see exactly how this works. It really doesn't work all that hard here. For like letter B, it would be like 8 out of 13 times 8 out of 13. Okay. For letter C, it would be like, again, 5 out of 13 times 8 out of 13. So there's the key difference here. You now have still the same 13 songs in the pool. And you'd have, again, 8 out of 13 times 5 out of 13. So um, the only key difference here between C, if it's with replacement, is, again, notice you have the same 13 songs in the pool here. And then you could just go ahead and figure out what each one of these. Yeah, the denominators does not change for with replacement because you're always putting that song back into the pool of songs. If you want truly randomly number generated, then that's exactly what needs to happen every single time. Is like you're putting it back into the pool. Was this 3787? And this is what's 0.4734. So that's what we get here for these cases as well. All right. Are there any questions about these? Any questions about these guys? Any questions? Nope. Boo. Hey. Okay. Great. Okay. So that is going to take care of it for today, everybody. All right. This is where we're going to end off here for today. All right. Thank you, everybody, so much for coming on out here to the stream once again. I know there's a few people that, maybe a couple of people that had a couple of questions. So I'm going to stick around a little bit after class time here. If you want to hop onto the Discord and ask me, you can go ahead and do so here. Yep, my Discord is wide open here. So, yeah, switch this over here. Put myself into the math thing. All right, so yeah, there we go. We should be set and ready to go. All right. So, so I want to thank you all once again for coming out here to the stream. Thank you, everybody. Everyone, have yourself a very, very wonderful weekend. All right. All right. And as always, everybody, stay safe, stay healthy, and most importantly, everybody, stay sane. Have yourself a great weekend, everyone, and we'll take it easy. Again, if you want to stick around, you can hop in the Discord there and ask me some questions. I got office hours right now, so certainly it's a good time to ask. All right? Otherwise, enjoy your weekend. Thank you so much, Planet. You enjoy your weekend too, okay? Have a wonderful one, and we'll see you on Monday. All right, everybody. Take care of yourselves. Uh, yep. Thanks, Ninja, for coming on out. I hope you enjoyed a little bit of math. I know it's something you may not want to remember, but that's fine. Yeah. Which notes do you need here, Athena? Wonderful. That's all that matters if you enjoy yourself there. Is it this one here, Athena? Oh, okay. Hang on. Thanks, JD. Move this underneath my face. Does that jive with my... Hey, it worked. Okay, good. Cool, cool. Cool, Athena. If you got questions, I'll take them now. Otherwise, you have yourself a wonderful weekend, okay? You ask Hazelnut here. All right. Cuckoo. Alrighty. Let's see here. Yep. Not sure where Hazelnut went, but I guess I'll wait. I guess I'll wait. Oh, oh, maybe the shit's skipped up. That's okay. Well, in any case, no problem. Technically, I am on the clock still, so I don't know if anybody's stuck around, but if you have any questions that you wish to ask, then please go ahead and do so. Oh, yes. Oh, I forgot to update it. Hang on. Hang on a second. I have to update my Discord. This. Gotta update that. No, no. Come back. Come back to me, please. Yeah. Yep. There we go. I just had to update the Discord link. There we are. Perfect. Ooh. Ow. Hello.
Oh, how you doing, Professor?
How's it going, my friend?
Doing good. I just had really just like one question, really. Are we
Yeah.
allowed to
Yeah.
ask questions about like the tests still?
If it's something, if it's a specific test question, then obviously I can't take that question. But if it's maybe a topic related to that, then yeah, I can certainly answer that.
Yeah, it was just like finding the mean and standard deviation of a frequency distribution.
Okay.
Uh,
So I can show you an example if that'll help.
yeah, or even just like where that was in the textbook, like what section that was.
Okay, so are we talking a grouped one? Like it just gives you the frequency distribution. They ask you to find. Okay, can you tell me what the mean and standard deviation were? Right? Or
Yeah.
or do they give you a data set? It depends which one because there's two different ways to do that.
I think they
So
give you a data set and then you oh no, maybe they don't give you a data set because I remember like oh man, I can't even remember now.
that's
Um,
okay.
let's see. I want to say they just gave you a frequency distribution because if they gave you a data set, it would be easier to find a mean and standard deviation. So I think it was just a frequency distribution graph.
Okay. Let me go and I'm gonna switch my camera here to the main cam. So want to get maybe it'll help. Um, so I'm gonna go to specifically in the book. This in section 3.3. If we're gonna kind of go back to that. Um, book. I think it's the right page. Yes. Okay. So
Or
that looks like this, right? They give you you see here on the screen where they give you the
um, what what
like
what's
some.
what screen do I where do I find a screen?
I'm on Twitch. So
Oh, so go back to the link. Okay.
go back to Twitch, right?
Okay. Yep.
And and then you'll see there on the screen where you see the book. I just posted on the main screen here on Twitch. So
Okay.
can you see that? You should be able to see that. So because I can see it. I can see it on my screen of me watching myself. So you see you have square footage and frequency and whatnot, right? Like a table like that. So you see that? You see that there, Des? Boom, boom, boom. Works. Hello? Hope I didn't lose you. I can't hear you, my friend. I cannot hear you. Okay. I can show you how to do that here, but yeah, I can't hear you. You want to just I'm guessing you're having an issue kind of going between the apps. If you're on your phone, then it would make sense. If you're on a computer though, you can run both apps at the same time. So, not sure why I can't hear you though. You sounded just fine a second ago. Um, did you mute yourself? Excellent.
And now can you hear me?
Oh, now I can hear you. I don't know what happened there.
Oh.
I was,
Oh,
I
okay.
was like,
Yeah,
I was like, what happened to you, buddy? You just like dropped out suddenly. I'm like,
yeah. I don't know what happened. It just like I was talking, all of a sudden, like, "Hello, are you there?" I'm like, "Can you hear me?" I was like, "Oh, I don't think he can hear me because I didn't see like the green thing."
Yeah.
So
That's why I put it there. I'm not sure why that happened, but
yeah, I don't know
okay.
either.
I don't know. Yeah, I'm assuming you're on your PC, right?
Yeah, I'm on a Dell.
Yeah.
Yeah.
Oh, sorry to hear that. Anyway, when you build your own computer, it's so much better. I promise you that. um, it's just so much better. Okay, so yeah, it looked just like these tables here. Just had frequency chart, had a like some kind of score range or whatever, and
Yeah.
then they ask you, hey, okay. So what we need to do here specifically is we need to do a couple things. So let's say we're looking at this example here. So I'm going to switch my camera one more time. I'll just take my face away here. And we're going to use the calculator for this part, okay? So our calculator is going to be our friend just like it was for the other guys. So let's go
Um.
ahead and do that right now. Yes,
So
sir.
how am I able to? Should I mute you on the Discord and then just have you on the Twitch stream then, so I'm not getting like two different audios?
Yeah, you can mute me on Twitch. So you
Oh.
can yeah. So you're on the PC, so you can't do it on a phone because you'd have to mute yourself on both apps because it works off the same volume. But
Okay.
on the PC you can just mute me on Twitch and then you can just talk to me here on Discord.
Okay. Yeah. Then that's efficient. Yeah. Okay.
Yeah.
All right. So I can see your screen now.
Okay, good. Okay, so all right, so now I'm gonna bring out the calculator here for this. All right, so kind of took my face away here. So what we need to do here first is I'm gonna first look at, let's say we're doing, I know the one I pointed out here was square footage. Let's do the square footage one, okay, for example. Okay, so for us to do that here, we're going to have to set it up in our lists, okay? So remember how you did that for our lists that we had from before?
Yes.
Doing our one var stats? Yeah. So we're going to set up two lists here. So we're going to go to edit. Now, if you have stuff already in there, remember to clear it out. So hit clear and enter to clear that stuff out. So clear and enter. Let's clear that junk out. Anyway, so in list one, we're going to put the midpoints for every single category. So every single class, we're going to have the midpoint for each of those, right? So the way we get the midpoint here for each class is we take the lower class limit of the first class, add it to the second class lower class limit, and then divide by 2. So in this case here, it would be 0 plus 500, and then divide that by 2. And then you would get your first lower class limit there. Does that make sense? Yes or no?
Yeah. You get 250.
You get 250, right? So we're going to put that here in list one. The first category or midpoint here is 250. Then
Okay.
we repeat the process here For the second category, now we do 500 plus 1,000, and then we divide by 2. So in that case there, we get, what do we get?
750,
We
right?
get 7. Yeah, we get
Oh yeah,
750, right?
because you
Right?
keep adding like you just add 500 to each category then.
Right. The first category is the most important one because, again, you need the midpoint here, but then you can establish a pattern for each category because it should be pretty predictable after that, if that makes sense.
Yeah.
Okay. So then you just keep adding by 500 after that to get every midpoint for each category. So again, I would do, like, for example, 1,000 plus 1,500, right? And then divide by 2, I get 1,250. Add another 500, I get 1,750. Well, you get the general idea.
Yeah.
Okay. And we could keep going down for every category all the way down. So there you get 2750, 3250, and finally we get 4750. Okay, so these are all the categories that we have here and all the midpoints for each one of those respective categories. All right.
Mhm.
Just let me know when you're there, and then I'll move on.
Yeah, I got the data points in.
All right, perfect. All right, second list here, we're going to put all the frequencies that you see on the screen, okay? So whatever those frequencies are, just going to plop them right into the second list, okay?
Okay.
And just let me know when you got that done.
Okay.
All right, cool. Okay, next we're going to go ahead and quit. So we're going to hit second and mode to quit to the main screen. Just again, just making sure we don't enter in any bad numbers because obviously we only want to do this once. So we're going to hit the stat key once again. We're going to go to our friend, one var stats once again. This time though, you notice we have the list being L1, which is fine, but we also want to now include a frequency list here, which is going to be L2. To
Oh,
get
okay.
L2 to get L2 to show up on your screen here, we're going to hit second and the number 2, and then L2 will show up on your screen here. And then you want to go down to calculate. Now you have a new style calculator, right? Just a
Yeah, I
newer
get the same. I
calculator.
get the same one that you got.
Okay, okay. All right, good, good. I only pointed that out because some people have older calculators, so
Yeah.
I wasn't sure which one you got. All right. So we're going to go to calculate here, and there you go. You see right up above there, you see you have the mean at 2419. And if you're looking for the sample standard deviation, that's going to be the SX you see there, which is 906.9643.
Okay. Oh wow. Yeah. Okay. That's so much easier than like the way I was trying to do it. Okay. Yeah. All right. Thank you so much.
Yeah, no problem. I'm happy to help. Hopefully that'll clear up any confusion for the test question there.
Oh yeah,
You'll
for
have a pretty
sure.
good idea about how to do it.
Oh, yeah, absolutely. Yeah. All right. Well, thank you so much for like sticking around and like walking me through that.
No, no. Do you have any more questions? This is like office hours time, so you feel free to ask me anything else if you like.
All right. Cool. Yeah. None for right now, but
Okay.
yeah.
All right. Good luck on the test there. Okay. Remember to get it finished by tomorrow. Okay.
Yep. That's good.
All right. Great. See you later. Have a great one.
All right. You too. Thanks.
All right. Bye. All right. If you need to join up on the Discord there, and again, if you do have some questions, I'll take some now. Um, Otherwise, I can end the stream here. So, yes, maybe. Okay. All right. All right, so looks like there are no other questions. That's perfectly fine. That is not a problem. So I want to thank everybody for coming on out here today. Thank you so, so very much. You're all very, very super kind. All right, we will talk to you again soon, okay? Again, feel free to email me if you have any questions. All right, otherwise, thanks everybody. Take care of yourselves, and we will see ya. All right. Have a great one. I'll be back at 6 p.m. today for some more stats. All right, bye.